Now we'll look at compositions of functions with numerical computations. Here I have 4 different functions described: f of x, g of x, h of x, and p of x. And the composition that I'm looking for is g of h of 4. We're going to start with the inside and work our way out. So we'll begin by finding h of 4. Remember, what this means is we're going to find the y value when x is 4. We don't have a graph and we don't have a table, but we do have the algebraic function itself. So the way I find the y value when x is 4 is simply by substituting 4 into the expression and figuring out what the answer is. So when I substitute 4 into h of x, I get 3 over 2 times 4 minus 2, which equals 4. So h of 4 is coincidentally 4. Now I take the 4 and replace it in place of h of 4, and I find g of 4. Well, g is 1 minus 2x. Substituting 4 gives me 1 minus 8, which is negative 7. So g of h of 4 is negative 7. This one is not really a composition of functions per se. We're just finding f of negative 2 and p of 2 and adding them together. So for f of negative 2, I'm going to substitute negative 2 in place of x, do the mathematics to find the corresponding y value. And for p of 2, I'll locate the p function over here on the right side, and I'll substitute 2 everywhere you see an x, and just do the arithmetic. So f of negative 2, when I substitute negative 2 in place of x, I get negative 15. When I substitute 2 into the p function, I get negative 4. And you may need to pause this video if you're taking notes. So now I can say, since f of negative 2 is negative 15 and p of 2 is negative 4, that negative 15 plus negative 4 is negative 19, which is my final answer. Again, if I go too fast, please just pause the video so that you can take your notes appropriately. Here's a composition of functions where I'm finding p of g of negative 1. Always work your way from the inside out. So first, simply find g of negative 1, which means I'll locate this g function, 1 minus 2x, and substitute negative 1 in place of x. So when I substitute negative 1 in place of x, I get that g of negative 1 is equal to 3. Now I'm ready to substitute 3 in place of g of negative 1 and find p of 3. When I substitute 3 in place of x in the p function, I get 0 in the denominator, which we know is mathematically not allowed. So I'm going to simply say that p of g of negative 1 has no solution. There is no such value. All right, here it says, if f of x equals 2x squared minus 3x plus 2, and g of x equals 2x plus 1, then find f of g of negative 2. As always, work your way from the inside out. So first, find g of negative 2. For g of negative 2, simply substitute negative 2 in place of the x in the g function, and you'll get an answer of negative 3. When you plug negative 3 in for f of negative 2, you will now find f of negative 3. When you plug negative 3 into the function of f, you get 29. Again, if you need to pause this video to take down these notes, please do so. For our next task, we have f of x equals 2x squared minus 3x plus 2, and g of x equals 2x plus 1. We're going to find an equation for f of g of x. I want you to notice that we don't have a specific value for x. We're going to be finding a new function, f of g of x. And it's actually quite simple. We're going to take g of x, the entire function of g of x, 2x plus 1, and we're going to substitute that into the f of x function. Everywhere you see an x in the f function, we're going to replace it with 2x plus 1. Can you tell that we've taken the g of x function, 2x plus 1, and substituted that in place of x into the f of x function? Next, it's really just a matter of trying to clean this up and simplify this expression as much as we possibly can. The first thing I notice is we have 2x plus 1 in parentheses squared. Remember, that means that 2x plus 1 is going to need to be multiplied by itself. I can go ahead and take care of the second set of parentheses by distributing negative 3 times 2x and negative 3 times 1. In the next step, I'm going to perform the FOIL operations to multiply 2x plus 1 times 2x plus 1. So that means that 2x will need to be multiplied by 2x, and 2x will need to be multiplied by 1. I'll also need to multiply 1 times 2x and 1 times 1. After I do that and combine my like terms, that's going to give me the expression 4x squared plus 4x plus 1. You might want to pause and think about how that's true for a moment. At the end of my expression, I note that negative 3 plus 2 is negative 1. In the next step, I can finally rid myself of these parentheses by distributing 2 times each of the 3 terms in the parentheses, and I end up with this expression. Finally, I will combine like terms. I notice that 8x and minus 6x can be combined because they are like terms. I also note the constants, positive 2 and negative 1. And so f of g of x can be simplified to 8x squared plus 2x plus 1. In task 3, it says use the equation that you just found for f of g of x to find f of g of negative 2. Now, we could do this the old way by finding g of negative 2, taking that value and substituting that into the f function as well. But since we've already found f of g of x, we can simply use this newly found composite function and substitute -2 in place of x, and we get 29. Actually, if you look back in this video, you will see that we found f of g of -2 the other way before, and it was also 29. Let's practice more compositions of functions with these. Pause the video and see if you can find g of h of x. Here, we're taking the function of h of x, 3/2 x minus 2. We're going to take the entire expression and substitute that into the g function everywhere you see an x. Well, in g of x, which says 1 minus 2x, there's only one place we see an x. But in place of that x, we're going to put the entire h function, 3/2 x minus 2. It's going to look something like this. Notice it's simply the g of x function where x has been replaced with h of x. This is a composite function. It's always good to clean this up a little bit. We can make this look a little bit better. First, we can rid the parentheses by distributing -2 times 3/2 x and -2 times -2. And that's a good idea because it also ends up eliminating fractions. So this looks much better. I have a couple of constants that I can combine. 1 plus 4 is 5. And so this composite function, g of h of x, simplifies to 5 minus 3x. All right. Pause the video and see if you can find g of f of x. In this example, you're going to take the entire f of x function and substitute this entire expression where x is in the g function. Doing so will look something like this. The g function says 1 minus 2x, but in place of x, we are substituting the entire f of x function, -x squared plus 3x minus 5. Once again, simplification is in order. I'll distribute the -2 times each of the 3 terms in the parentheses. And I get this expression. In my final step, I see I have a constant of 1 and 10, and certainly I can combine those together to make this look nice. So g of f of x can be written as 2x squared minus 6x plus 11. Pause the video and see if you can find f of g of x. This time, we're going to take g of x, which equals 1 minus 2x, and we'll substitute that expression into the f function both places x appears. And it will look something like this. Notice this is the f of x function where x has been replaced with 1 minus 2x. This is a composition of functions, or sometimes called a composite function. Once again, our job at this point is simply to perform some algebraic manipulation to try to make this look a little bit nicer. And we certainly can. When we note the binomial 1 minus 2x is to be squared, remember that means that we're going to have to multiply it by itself. And we don't simply square each term. I did go ahead and distribute the 3 to the second set of parentheses. 3 times 1 is 3, and 3 times minus 2x is minus 6x. It's important here to write neatly and show all of your steps so that you don't mess up. I'm going to perform the FOIL by multiplying each of these first two terms by each of these second two terms so that I can get rid of some parentheses here in this expression. When I do so and combine my like terms, I get 1 minus 4x plus 2x squared. Actually, this is supposed to be a 4. I see that that is an error. So this final answer is not going to be quite right. But I distribute the negative sign, which of course changes all the signs in this parenthesis. Now remember, this 2x squared should say 4x squared. So when you're taking your notes, make the minus 2x squared of 4x squared. Again, I have some like terms. The 4x and the minus 6x can be combined, and the minus 1 and the minus 2 can be combined. 4x minus 6x is minus 2x, and negative 1 minus 2 is negative 3. The minus 2x squared, please remember, that's supposed to be a minus 4x squared. So I ask you to just forgive me for that error, and please correct that in your notes and put a minus 4 here. Pause the video and see if you can find P of g of x. This time we're taking the g function 1 minus 2x, and we're going to substitute that into the p function. Where you see an x, you will replace it with 1 minus 2x. So you have 1 minus 2x plus 2 in the numerator, and 1 minus 2x minus 3 in the denominator. Combining your like terms will give you 3 minus 2x in the numerator and minus 2 minus 2x in the denominator. And there's not much I can do to simplify that, so I'll just leave it like that. Part E says find an equation for negative 6 times h of x minus f of x. So I'm going to take the function h of x and substitute that here, and f of x and substitute that there. When doing so, the expression looks like this. Once again, I just need to do some simplification to clean this up as much as I can to make it look nice. So first, I'll distribute negative 6 times the two terms in parentheses. Negative 6 times 3 halves x is negative 9x, and negative 6 times negative 2 is positive 12. I'll also distribute the minus sign in front of the parentheses to each of the terms inside of the parentheses, which will simply change all the signs. My final step is to combine like terms, and I like to put my variables in descending order with respect to the exponents. So I'm going to put x squared first, then my x to the first powers, negative 9x and negative 3x make negative 12x. And finally, my constants, 12 plus 5 is 17. And so I've simplified the expression as much as possible, and that would be my final answer. This time, we're going to find f times g of x. Remember, that just means that we're going to find f of x and g of x and multiply them together. But f of x is negative x squared plus 3x minus 5, and g of x is 1 minus 2x. So I have a trinomial times a binomial. This can be very tricky. You have to remember to take each of the three terms in the first polynomial, or the first set of parentheses, and multiply each of those times each of the two terms in the second set of parentheses. So you have to be very careful. Negative x squared times 1 is negative x squared. Negative x squared times negative 2x is positive 2x cubed. Next, 3x times 1 is 3x, and 3x times negative 2x is negative 6x squared. Negative 5 times 1 is negative 5, and negative 5 times negative 2x is positive 10x. We did it. Finally, let's combine our like terms and put this polynomial in descending order with respect to our exponents. So I'm going to put the 2x cubed first. Next, my x squareds. Negative x squared and negative 6x squared makes negative 7x squared. Next, come my x to the first powers. 3x and 10x make 13x. And finally, my minus 5 constant has nothing with which to combine, so I just place it there. And that would be my final answer for f times g of x. In this example, it says, for what values of x is f of x equal to g of x? Well, we're simply going to set the two functions equal to each other and solve. I notice there is an x squared, which tells me this is a quadratic equation. In a quadratic equation, it's good to get all the terms on the same side. So I'm going to subtract 1 from each side, and I'm going to add 2x to each side. So the right side is now 0. I notice that all my terms are negative. If I multiply both sides of my equation by negative 1, I could make my life a little bit easier because now everything on the left side is positive. When solving a quadratic equation, I really like factoring because I find it's very simple and straightforward for me. But this trinomial is not factorable. So I'm going to have to resort to some other method. My next go-to might be the quadratic formula. So let's solve using the quadratic formula since this trinomial is not factorable. Remember, the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A, b, and c are the coefficients of x squared, x, and your constant. Notice that the coefficients of x squared and x are invisible, meaning they're both 1. So we just substitute these values into the quadratic formula and carefully solve. Simplifying the radicand, the number under the radical sign, we get negative 23. This is problematic. In the real number system, the square root of negative 23 does not exist. So I know that this is not going to have a real solution at all. So that was a lot of work to say there is no solution that will meet this demand. Next, we'll find an equation for g plus p of x. That simply means we're going to take g of x and p of x and add them together. So we get 1 minus 2x plus the fraction x plus 2 over x minus 3. I could get a common denominator and combine all of that together, but I think you get the point.